Hey guys, this is Mrs. Figueroa. I was going to go over the Unit 2 additional review. I passed this out to my students, but if you're in Mr. Engstrom's class, I would just look at the exercises that are referenced here. So page 32 in your Unit 2 exercises. Like this one is exactly the same, but if you look at number 13 on here, the things are in red. That means I changed the example to match kind of the things that are not on the test. That are on the test that we have not covered in class, or on the guided notes. So for this video, I suggest watch me do like the first example first and then like pause the video and then try to do it on your own to try to see if you understood the concept. So in this first example, it says last weekend police ticketed 18 men whose mean speed was 72 miles per hour. And then it gives us data for females. So it says 30 women have an average of 64 miles per hour. Miles per hour. And then the question is asking for overall, what was the mean speed of all the people ticketed? So on the exam, it won't be exactly like this, but the idea is there. So it's going to have like two different means, and then you're going to combine them to get like an overall mean. So in order to do that, just think about what mean represents. Mean is average. So in order to get the average, if I had the males, for example, it gives me that the mean ends up being 72. But how do you calculate the 72 is you go add all your values, and whatever you get for your total, then you would have divided by 18. So to solve for my question mark up here, I would multiply by 18 to both sides to cancel, and that'll give me my question mark. So it's the same concept here. So I'm going to have to do 18 times 72. That will give me my total for my males, and then I'm going to go add the total for the females. So my total for the females, doing like the same overall concept, I have 30 women and their average was 64. And to get the combined totals, I need to add my total number of things I'm dividing by. So I'm dividing by 18 males and 30 females. So if you were to calculate that in the calculator, it ends up being like 3,216 over 48. And if you calculate that, it gives you 67. So the answer would be part A, 67. But this is not going to be a multiple choice question on the exam. It will actually be on the free response portion. So make sure you definitely know how to do that for tomorrow. Okay, now if you want, pause the video now and then try to do number 2. Okay, hopefully you paused it and you tried it. Now, number 13, again, if you're not in my class, this is on page 35, unit 2 of the exercises. But if you're one of my students, you have a handout like this. So, the histogram above shows the number of minutes needed by 45 students to finish playing a computer game. Now, the question, this is in red because I changed the question that's actually on the exercises. So, the question that I am asking is, what would be the median number of minutes needed to finish playing a computer game? So if you think about what median represents, median is halfway, right? So to figure out halfway, you would take half of 45, and half of 45 would give you about 22.5. But that doesn't mean the median is 22.5. That means that's the number 22.5 on your list. So on your histogram, you're going to want to go count either 22 this way or 22 that way, 22 and a half, and then that'll give you approximately where the mean is at. I have most of my data on this side of the histogram, on the right side of the histogram, so then I'm going to count 22 this way because it's going to be just less adding. So this bar tells me frequency over here. I have 9 students were between 19 and 21 minutes, and then 5 here, and then I have 9 over here. So if I go add that, 9 plus 5 would give us 14. Plus 9 would give us 23. So I needed 22.5. So from here to here, I have 23 data points, right? So 22.5 is gonna be it's like almost right in between those two right there. So remember, this is a left-sided histogram, meaning whatever this number is, it's actually on the left side. So the 5 goes in that second bin, which means you can't even see anymore, but the 15 right here is actually in this bin. So in this bin, let me change color because you probably can't even see what I'm doing. So in this specific bin where the 9 is at, that is specifically numbers 16 and 17. So because the data median has to be 22.5, and I have 23 on these data sets right here, my 22.5 is actually going to be somewhere in between there. So I would say then the median for this specific example is going to be either 16 or 17. It doesn't have to be an exact answer, but on the free response portion of your test tomorrow, it's going to ask you like to approximate what the median would be. So that's the process of how you do it on a histogram. You have to look at the frequency on the side, count the add up the frequencies up until the median, and that'll give you where the value should be. So again, you can pause the video and then try on your own. So let's move on to the next example. The next example says, consider the following back-to-back stem plot. And then it says, calculate the smallest and the highest value a data could be in order to not be considered outliers. And I just didn't have another example, so I'm going to cross out this side because and then this is on the multiple choice portion of your exam. On the multiple choice, you're only going to have like one of the sides on the histogram. The stem and leaf plot. So in order to calculate the smallest and highest, in order to not be considered outliers, anytime it asks for outliers, you have to calculate the fences. So in this example specifically, it's asking calculate the smallest and highest value. So this is the smallest is asking for the lower fence, and the highest value is asking for the upper fence. So in order to do that, you need to know what Q1, Q2, and Q3 are. So Q1, Q2, which is the same thing as the median, and then your Q3, and that'll help you find the IQR. So in order to do this, you have to actually put this in your calculator. So if you go to your calculator, we're going to have to do data and statistics. So we're going to make a document, menu, add list and spreadsheet, and I'm going to put the data for my stem plot. So then it's my stem plot, so I'm just going to put, stem on here. Stem plot. Doesn't really matter what you call it. So stem plot. And then I'm going to go down my list and put the values there. So if you look back here, this means I have 0, 3, 0, 4, 0, 8. Then I have 10, 11, 12, 15, 16. Then 22 and 29, 32, 35, 35, 37, 56, 61, 64, 65, 68, 70, and 79. So go put those values in your calculator. So again, if you go down the list, it would be like 3, 4, 8, 10, 11. Oops, I missed the one there. So 10, 11, 12, 15, 16, and keep going. I'm going to pause the video and allow you guys to put the rest of the data. Alright, once you have the rest of the data in your calculator, we're going to have to go to one variable stats in order to calculate the quartiles. So go to menu, stats, stat calculations, one variable stats. I only have one list, and my list, I named it stem plot, and everything else stays the same. You press OK, so then you're going to go look for your Q1, median, and Q3. So I have my 3 data sets right here. I have Q1 is 11.5, my median is 32, and 62.5. So go put that in our paper. So we have 11.5. I think the other one was 32 and is 62.5. So if we calculate the IQR, just do 62.5 minus 11.5. That's going to give us 51. So in order to calculate the lower fence, you're going to do Q1 minus 1.5 times the IQR. So our Q1 is 11.5 minus 1.5, and the IQR is 51. We're definitely not going to have any outliers here. So that ends up being, for your lower fence, negative 65, if you calculate that. And then this is going to be the smallest the value could be in order to not be considered an outlier. And then I'm going to do the upper fence. So the upper fence is Q3 plus 1.5 times the IQR. So Q3 is 62.5 plus 1.5 times the IQR. Your upper fence ends up being 139. So this is the highest a value could be. So as soon as you get 140, that means 140 would have been an outlier. So that's how you calculate the lowest and the highest value it could be in order to not be considered an outlier. Okay, next example. Here it says you have a box plot, and the box plot represents the amount of pennies. 374 pennies were collected, and it gives you the 5-number summary for the distribution are 0, 3, 10, 19, and 50. So what that represents is 0 is the minimum, 3 would be like your Q1, 10 is the median, 19 would be Q3, and then 50 is your maximum. And then the question is about how many pennies are 3 years or younger. So I have already gone over this in my class, so just in case you were absent the day I talked about it, you need to know what it's asking. So it's asking for 3. So if you look at 3 specifically, 3 is your Q1. So 3 specifically is the Q1. But Q1 is the 25th percentile of your data. So 25% of your data would be 3 years or younger. So in order to calculate how many pennies, you take your total 374 times your 0.25%, and that'll give you how many pennies there is. So that ends up being 93.5 pennies. So 93.5 pennies are 3 years or younger. Okay, so that's how you would do that one. And then the one for the second part is asking for 10 years. So 10 specifically is your Q2, which is 50% of your data. So do the same thing to calculate Q2. And then the 19 specifically is your Q3, which is 75% of your data. And that'll help you answer that part of the question. So go ahead and do that one. I'm running out of time, so I'm going to have to make a second video for the very last example. Okay, so I went ahead and I did the work for the Q2 and Q3 to figure out. So double check your answers. I will have to make a second video for the last example, so make sure you watch that video also.